All right, everyone. So in this lecture, I'm going to go over load factor and some of its implications. This is a continuation of a homework 4. Okay, so what is load factor? Load factor is your average demand over divided by your peak demand. This is usually calculated over the course of 1 month. Okay, so there's really two ways to calculate it. One is the average demand that month divided by the peak demand that month. Or you can take the actual kilowatt hours used, divide that by the kilowatt hours that would be used if the building operated at its peak all month. So let's use the first definition here. So average demand divided by peak demand. That's your load factor. So let's look at a sample chart here. So this chart shows the average demand each hour of the day over the course of a month. Okay. So on the y-axis we have our demand, right, in kilowatts. Okay, and then this is time of day. So if we take the average demand divided by the peak demand to find our load factor, if you look at these two charts, you can see that this one right here in pink has a load factor of 0.75 and the blue has a load factor of 0.25. So what this means is, with the high load factor here, that means the average is pretty close to the peak. Whereas with the lower load factor, the average is much smaller than the peak. Okay? So high load factor means the average is very close to the peak. Low means there's a big discrepancy between the average and the peak. And you should be able to pick up with these two charts that the pink here with the squares, if you think about the average of that, I mean, it's somewhere between 120, let's say 120 to 125, right? And then my peak is around 150, right? So my average is really close to my peak, which means I have a high load factor, okay? Whereas the blue line with the diamonds, you can see that the average is probably somewhere around here, probably about the same average. But the peak is much, much higher, right? And so what that means is it's what's often referred to as peaky, okay? And that is a low load factor means it's sort of like spikes and drops, and then, sort of average and spikes and then drops and so on, right? Whereas a high load factor, it's pretty even. It's going to go up and down a little bit, but there's not going to be those big spikes. Okay, and so this, if you think about what this tells you, it just tells you the pattern of power use over the course of a month. And the load factor gives you this nice snapshot of am I having big, huge spikes in demand and then dropping, or is it pretty steady all month, right? And that's really what it tells us, and that can actually be really helpful when we're doing an analysis. So let's look at how we calculate that. I'll look at a couple of examples here. Before we do that, I want you to think about what types of buildings would have high load factors and low load factors. So for example, if you had a school with a load factor of 0.8, would that be normal? So should a school have really steady energy use, or would you imagine some pretty big spikes throughout the course of a month? And I'll let you sort of think about that and let it marinate while I go over some of these calculations, okay? Because that's where it really becomes useful. All right, so how do we calculate load factor? There's really two ways, and I don't care how you do it. It's up to you. Okay, so here's our two separate formulas. We can either do the average kilowatt divided by the peak, or the actual kilowatt hours divided by the kilowatt hours if it was operating at the peak the whole time. So let's start with the first one. Okay, so we have a 30-day period. A building uses 500,000 kilowatt hours. If the peak demand was 1,000 kilowatts, what is the load factor? So feel free to press pause and see if you can calculate it using this formula. Okay, so we know the peak, right? So we need to know average and we need to know peak. We know peak demand, it's 1,000. It's given to us, okay? Easy peasy. But now we need to figure out the average. So if you think about the units of this, if we have 500,000 kilowatt hours over 30 days, we just do some basic unit calculation, right? So 500,000 kilowatt hours, 30 days, 1 day is 24 hours. And when you cancel out the units, you end up with kilowatts. So my average kilowatt usage, my average demand was 694 kilowatts. So now I have my average. I already have my peak. Divide, and we're good. Okay, so 694 divided by 1,000 kilowatt. Notice that the units cancel out, and so 0.694. Okay, not super hard math. So let's do it the other way. Okay, same building, same energy use, same amount of time. So let's do the second one. Actual kilowatt hours divided by the kilowatt hours that it was operating at the peak. Okay, so actual kilowatt hours is given, 500,000 we have. So what would the total use be if we used the peak demand all month? So we know our peak demand is 1,000 kilowatts. We can pretty easily figure out how many hours are in the month. So we multiply kilowatts times hours, and we have our kilowatt hours. So let's do that. 1,000 kilowatt hours, 30 days per month, 24 hours a day, 720,000 kilowatt hours per month. So that's if we were operating at this peak all 30 days straight, right? So total demand the whole month. Okay, so now we divide the two and divide one by the other. 500,000 divided by 720,000. Again, the units cancel out. We're left with 0.694. Same exact answer. So, like I said, it doesn't matter how you calculate this. It's up to you. Whatever makes the most sense to you is fine. It does not matter to me as long as you understand what it means and how to do it. Okay, so let's do another quick sample with a slightly different building. So remember, this first building was 30 days, 500,000 kilowatt hours with a peak demand of 1,000 kilowatts. So now we have the same exact energy use, same time period, but the peak is higher, 1,500 kilowatts. Right, so let's use our first method. All right, so we have our peak. So we have our peak, 1,500 kilowatts. So what's the average kilowatt for the month? Again, we've already done this calculation, so it's 694 kilowatts. Our peak is 1,500. So now we have a load factor of 0.462, right? So for this example, the average stayed the same, but the peak went up, so your load factor goes down, right? Remember, it's average divided by peak. So if I hold that average the same and that peak goes up, that's going to drop my load factor. So I think you can probably intuit a basic relationship here. If my total use or my average use goes up, my load factor is going to go up, right? So you're just dividing that by the peak. So if the peak stays the same and the total use or the average goes up, load factor is going to go up. Total use or average goes down, that's going to go down. And then on the denominator, right? So if my peak goes up, my load factor is going to drop. If my peak goes down, my load factor is going to go up. Okay? And so, okay, why do we care? So I want you to think about what load factor tells us and whether or not that is normal, okay? What that indicates overall. And so let's go back to one of our original questions. So if a school has a high load factor, so a school, say 0.8, would that be normal? I want you to think about that. And hopefully you should, a school, if you think about the energy use pattern over the course of a month, it's going to go up and down a lot, right? Because the school's going to close, everyone's leaving, the lights turn off, the heating and cooling should turn back. The weekend, the energy use should drop. Overnight, it should drop, and so forth. It's going to vary a lot throughout the course of the day, which means it is peaky, which means it should have a low load factor, right? So peaky is low load factor, right? So it spikes and then it drops. So it's very typical for a school, like everything turns on in the morning, you have this big spike and heating and cooling and lights and equipment and all that stuff. It goes spikes up and then it drops once things sort of even out, and then it'll change a lot throughout the course of an average day. So it should have a relatively low load factor. Whereas a manufacturing plant, think of something that's just spitting out widgets of whatever 24/7, right? All this electronic equipment, all this, there's not much change in that building throughout the course of the day. Yes, it gets colder and hotter, so you have to use more heating and cooling. Maybe some lights turn on here and there. But generally speaking, you would expect a pretty high load factor for a manufacturing plant, right? Because it's a pretty consistent energy use. Whereas a low load factor, again, if I get a 0.4 for a school, that's probably about right. Maybe a little bit lower. Maybe a little higher depending on the total use, but that's in the ballpark, right? Whereas if I have a manufacturing plant that has all three shifts, is manufacturing 24/7, I would not expect a very low load factor because I should have a pretty constant load. And so if I'm analyzing a school like your school and I get a load factor of 0.8, that would tell me that it really shouldn't look like that. That means that they're using it means one of two things, really. Either they're using a lot of energy constantly, or they're using a relatively low level energy constantly. So you'd have to dig into the bills, but that's not normal. you should expect these spikes for a school. So again, it's this sort of snapshot, and it's like, hey, if I get a high load factor in a building that should have really peaky use, there might be something wrong there, and it would indicate that I need to investigate that further. Whereas if I got a 0.4 for a manufacturing plant, I'd be like, wait a minute, something's going on here. Like, I would think there must be some point in the day where everything's like turning on all at once, and it has this big spike and then drops. And that's abnormal, and that can, if you go back to what we were talking about before, that means that the peak demand is probably higher than it needs to be, and so there may be an opportunity for energy and money savings if they're paying for demand, right? So they're having this unusually high peak demand, and that could indicate that there's an opportunity for energy savings. And the same with a school. Again, if they're using a lot of energy use constantly, there's probably an opportunity for energy savings. Maybe not demand savings, but certainly energy savings. So there's all kinds of implications here. But load factor is just one way to help sort of enhance your understanding of a building energy use. Okay, and that's it for the load factor lesson.